Hello everyone, welcome to Huawei's Routing and Switching Lab. I'm your instructor Jay Mehta, and in this lab session we are going to connect two PCs in eNSP, and we are going to monitor the traffic flowing through them through Wireshark. So let's get started. Now the first thing that I need to do is I need to open eNSP. So I'll go to start and type eNSP. Yes, so my eNSP software is up. Now I can go to new topo, and in new topo I'll click on end devices, that is this PC icon, and in the PC icon I will click on PC and then go to the connections icon and click on copper and then click on PC1, which shows that I can use the Ethernet port 0/0/1. I'll click on it and then I'll click on PC2, and in that the Ethernet port 0/0/1. Okay, so now you can see that both the PCs are connected, but it does not display which interface is that particular cable connected to. So if you want to have that particular display, so this is a small topology, so in that you might not need it. But if there is a big topology, if you have a switch and in that switch you have 20 PCs that are connected to it, so you might want to know that PC1 is connected to which interface of that particular switch. So at that time what you can do is you can use this particular option that says show all interfaces. So once you click on it, it will display the cable is connected to which interface of the PC. So same applies for a router as well as for a switch, right? So our coming back to our task, so we have opened eNSP, we have created a topology of two PCs. Now we are going to rename them as H1 and H2, where H stands for host. So in order to rename, I just need to double click on this PC1. Okay, so I need to keep my cursor over there and I need to double click. So here you can see it opens up and I can now write H1. Same way I'll do it for the PC2. So yes, so I have renamed them as H1 and H2, and now I'm going to assign an IP address. So for assigning the IP address, I'm going to use the network which is 192.168.1.0. So coming back to the eNSP, so host name, I'll type it as H1, IP address 192.168.1.1. The subnet mask will be 255.255.255.0. I'll click on apply. Same way, I'll go to PC2. H2 is the name, and the IP address is going to be 192.168.1.2, and the subnet mask is going to be 255.255.255.0. Click on apply. So you can see that the interface is still not up because you have an amber light that is representing that there's no communication that can take place at this time, and the reason for that is both the PCs are turned off. So I can right click on it and then I can go to start. Same way I'll go to host 2 and I'll turn it on. So here you can see that the interface has now gone green, which means that now it can facilitate any communication. So we have assigned the IP address. Next is I'll open Wireshark to capture the traffic. So I'll go to host 2 and then I'll click on capture data Ethernet 0/0/1. Okay, so if you are transmitting your traffic from host 1 to host 2, so host 2 becomes the receiver and at the receiver is where you will be getting the packets, and that is the place where you would have to open up the Wireshark interface. All right, so yeah, I can see that the Wireshark interface is up. Now I'll go to host 1. From host 1 I'll be sending out the packets. It will be ICMP packets. So to send out the packets, I'll be going to the tab which says command, and over here I'll be using the command which is ping 192.168.1.2. So just to make it visible, okay, yeah, so I'll have them next to each other. Okay, yes, okay, so I'll click on enter. So you can see that the packets are being sent at the same time the packets are being received. So I have sent 5 packets and I've received 5 packets. So same can be verified from the interface of Wireshark as well. I'll maximize it. So here you have it. The source IP was 192.168.1.1. Destination was 1.2. It was a request for a ping and we got a reply, so on and so forth. So in this way we can observe the flow of packets in Wireshark. We'll stop it. So our last task was to open Wireshark and ping from PC1 to PC2 and check the Wireshark for the captured packets. So that is done. So this brings us to the end of this lab. Thank you so much for watching.